Hello, this is Dan Humberg from harvestfires.com. If you're watching this, you may have a Firestop kit on your combine. It could be a John Deere 9770, could be a 9670, could even be one of the last of the manufactured 9760s that used the same engine. The reason that I'm making this video is to help you with possible installation of a patch kit or a couple of extra pieces of tin and one replacement piece on the kit that can improve the kit's ability to resist penetration by sparks, or excuse me, by dust that might cause sparks on your combine. What you're looking at is a CAD model of the tin set for the models that we spoke about, the John Deere 70 series, generally the 9770 and 9670. What you're seeing is the tin as it has been typically shipped, or as it's assembled on the machine as it's been shipped. I'll show you the place where I'm concerned about dust penetration. That's right in this area right up here. You can actually see through that space right now, and since the radiator fan would be looking the same way we're looking and blowing hard at this, it looks like you have a really large hole into the enclosure here. It's actually not that it's tighter than what it looks, because there's a box shaped piece here that's part of your turbocharger wastegate actuator control, or whatever. That box fills much of this space. However, there is a bit of a little gap up here, and I don't like that, because if the radiator is blowing air into that space and we aren't blowing enough air out to resist that blast of air, then you could get dust entering there, and the turbocharger exhaust turbine is actually right back here, right behind that spot, and if that dust reaches that exhaust turbine, it can very possibly ignite in there, or build up and then eventually ignite, and then have sparks exit where air is leaving the box. So we want to try and tighten that up a little bit. There is another video that actually shows some of this same stuff, that shows you how you can tighten that up just with tape, and you can use that aluminum foil tape that is shipped with the kit and possibly tighten this whole area up. If you do that, follow the instructions for that on that video, and tighten up a lot of these small openings here. After I went and looked at a subject machine where the guy had initially had no fires, but then started having some smolders later in his sunflower harvest in the fall of 2018, I went and looked at that machine and decided to redesign the parts that integrate with that turbocharger wastegate actuator in this area. And so what I'm going to show you is what's changed, and how to install the pieces that I've created to try to make this inherently a tighter location, or a tighter, smaller spaces for air to exhaust, so that the air inside builds up to a little bit higher pressure and keeps the dust out from the radiator blast. So the part that's highlighted here, this orange highlighted part that you might be seeing, is actually part number 10 in the kit, at least the current numbering of the kit parts. That's part number 10, and it's designed here to fit into the bracket it's a cast iron bracket that supports connects the wastegate actuator and control box to the turbo itself. But it's a complicated shape. That cast iron piece is a really weird shaped piece, and so it's very difficult to design something that fits really close up against it and prevents air which goes in over here, from turning around and circulating around, turning right around and coming back out around that. So we want to try and tighten that up. So I'm going to take this part, and you're looking at the assembly drawing of this stuff, and I can take that part and say I want to delete that part from this diagram. So if I take that one out, that will leave the 6 holes in the vertical panel here, and a larger hole here where that part came out, and your wastegate actuator arm operates up through here to change the geometry of your actuator. Now if I go to say show all of the pieces, well, I'm going to change that. I'm going to undo that step. I'm going to insert a part. Here's the part that I want to insert. Just a minute, I have to tell it to keep that. Okay, so this is a new part that will cover over that cast iron piece. It still allows space underneath for the moving parts to move, but it will fit in, wrap around that piece, and hopefully tighten that space up somewhat. There are 6 holes in this piece of tin here. They should line up with the holes on the original vertical wall there. And so when you put this piece on after you've folded it, and that's a separate video to show you how to fold make the bends on this piece. You can also look at this video and probably see how to do it. You have the 6 vertical holes here, and here's the shape of the back side of that piece, or the outside of it, and then these others flanges fold over and then down. Sorry, get that blown up here. And this one folds around and back in, and this bottom one folds over and then up. And these 3 flanges here, this one, and this one, will slip in between the wastegate actuator control box and this cast iron housing or mount that holds it all together. And they should slip down in between and kind of lock this around that piece. There will be some little holes at the corners here because there are bolts there, and in here, and right up here. And so you could have to trim this a little bit to fit around those, but hopefully that these pieces should fit around those bolts and in between that space. The space is about the width of the bolt head in between those two. But that's the piece that it's piece number 10. It'll replace the old piece number 10 on the kit, and it will slip in over this cast iron piece. And you may need to bend these flanges a little bit or flex them a little bit in order to get them to pop in place in between the control box to the right and the frame that we're surrounding. But it should fit in there. One thing, when I look at this and I see the slight angle on this piece, it's possible you could have to torque this box a little bit, twist it probably a little bit clockwise. The part that I did this on site with very lightweight tin and made a piece that fit, and it fit all right, and then I unfolded that piece and copied that and worked that into the CAD, the computer file here, or the computer drawing system here. But when I have it on here, it looks to me like this is slanted just a little bit, and it's actually should probably be a vertical panel or a vertical line parallel to this one here, to this one, this line here or this line here. But the tin is ductile enough that you could twist this whole thing a little bit to make it fit in that space, and I don't think that will be a problem. There is a tab up here on the existing tin that you can bend up out of the way, and then this piece will slip in here and kind of slip into the space up here where I was concerned about there being a gap. It may fit underneath this existing tin here. If it doesn't, you could have to trim a little bit again off the highlighted piece there for it to slip in there, but try to make it fit in there. Without that, it really should fit in there. Then we can add the other 2 pieces. This will be quicker. I'll just say show all, and now it's going to add in these other 2. These are new pieces that I'll send you if you're getting these getting this supplemental kit. The first one that I would put on is likely this one. It's highlighted at the bottom. It has a slot cut in it to fit around the oil line to the turbocharger bearing. That oil line will come over from the left side here and then dive down at an angle through this hole, through this slot, go underneath the compressor turbine, then it goes up forward, and then it angles up and it comes back into that bearing. There's a long tortuous path for that oil line from where it leaves the engine way down on the other side and comes up and wraps around and goes through here. I'm not quite sure why they made it such a complicated path, but they did. So we need to wrap around that with this slot. There's a slit in here so that you can pop this thing open and slip it around that oil line. You may wish to take a pliers and just bend the edges of this opening. In my case, I would probably bend them in to accommodate that piece, but bend them so that there's a little bit of an edge that is parallel to the oil line and not the hard edge of this cut tin up against that oil line. You'd like to have a little bit of clearance around the oil line, and if you do have an edge that's going to touch it, you want it to be a smooth surface and not a sharp or hard edge. So if necessary, bend this. It's light enough tin, you can take a pliers and just grab maybe 1/8 of an inch of it and bend it hard over so that it has a 90 degrees or a surface that is parallel to the oil line instead of 90 degrees to it. So that piece is supposed to slip in kind of underneath this bracket that we just put on, and this one I would put on with 4 screws here. The bottom holes are to tie both pieces to the vertical wall here. So that's supposed to slip under kind of from left to right. In this case, it should fit down. These bottom surfaces should come very close to the valve cover or the head of the engine. And so it slips in underneath this piece. Now, when I do it in the CAD model, I see that there's a kind of an interference here. Let's see if I can show that. If we can look down through this hole. There, you see how that tongue on this piece appears to stick down through there. So there's something that you're going to have to modify when you get on here. We'll get this. That could be done in a variety of ways. You could bend this tongue with the pliers or something, bend it up if it will fit up and not interfere with anything in there. You could bend it down so that the other piece slips in behind it and it kind of parallels this face. That might work. Or it may be that it fits in place over the top of this in actual use on the combine. But I made those pieces from tin that actually fit on a combine, but that was very lightweight tin, and then I used the dimensions measured off that tin to enter it into the CAD model, and when I put it on here, it just seems to be an interference fit. So I wouldn't cut anything until you test fit it, but you may need to figure out how to make that tongue clear this. You could cut a notch in the top of the piece for it to fit over that, or any way you can do that. You just don't want to leave a gap. You don't want to leave very much of an opening if possible behind or around any of these parts. So that piece goes in there. It has 2 screw holes here. It'll go on over the top of the other piece up against the vertical wall here, and you can screw it on in place. Make sure you've got clearance around the oil line, and then you can use some of that aluminum foil tape to actually close up this slot around that oil line and make sure that it can't leak very much air out around that and can't get dust in around it either. The last piece is this dark blue piece here. It has it really just has an L-shaped flange on the edge here, and it will slip down from the top. You'll push it down in from the top. What you can't see is you got a box here. I don't have that illustrated. I just have my parts here. But there's this actuator control box here, and then on the back side here, the exhaust turbine is going to run here in this space right here. I'm sorry, not exhaust turbine. The compressor turbine is in there, and this piece illustrated here, outlined there, will fit up against the outside face of that turbine, that compressor turbine. This piece will also fit up against the outside face of that turbine. It'll just extend up a little bit higher. This one down here is not shown in the actual position it's going to be in, because I couldn't tell exactly where that was going to be because I didn't have the exact dimensions of the turbine. So when you put it on, you just slide it up against that and screw it down. Now this piece will slip down just out against the outside of the exhaust or the compressor turbine and slip down in between here, and it has a hole. Should have a screw hole down here. Don't see that screw hole. I don't know where it went. Oh, I put those screw holes in another little program. It will line up with the screw hole you see in that other piece. So that where you see that hole there, it should line up there with that one. And I'm not sure. Whichever one has the larger screw hole is the one that lies on top. Perhaps the gray one here lies on top. I'm not sure. I might have these in one behind the other one. But this one will slide down, and it should come down about to where it's illustrated here. It should come down even with the other one, and it'll probably just kind of buttoned in up against the plate that's on this surface here. Anyway, you should be able to put a screw through the bottom here, and then there will probably be a screw hole up here as well, and you may be able to screw that piece through against this flange that's shown behind there. And there probably won't be a hole in that one because this piece didn't exist when I cut that one. And so, but you can shoot a screw through because they are self-drilling, self-tapping screws. So you'd like to be able to shoot it through and tie this piece, this extension on this piece through to tie it to the piece behind it. Right, somewhere hit this piece back here. Also, this little tab here should fold down now and capture this bit behind here, this one. So this should fold down and kind of overlap that so that you have it helps tie those two together and cover up any gaps in this area. So that's how those three pieces are intended to go on to the existing 9770 tin set. So you're going to do three things. You're going to replace the existing piece here, part number 10, with this one, which is bent such that it should fit around the cast iron bracket and slip in between that bracket and the control box. You can torque it, like I said, a little bit. You can trim it if you need to make it fit around the other parts here, and that's possible because this process wasn't a perfect process to do this particular design. But it should help to tighten this up. Then I would come in with tape, and I'd tape around the oil line to immobilize that and stop any loss of air there. And I would tape around these corners if necessary where it joins the control box. And if necessary, I'd tape in here to tighten up any little gaps around in here where these parts meet the vertical or these other faces. And you can tape anywhere you see gaps to prevent air from getting from exhausting out and prevent dust from getting in there. So that's how to put on those pieces. In the other one, I also show you in the other video, I show you how to tighten up where that oil line, this is where that compressor or that turbo bearing oil line enters, and I would use tape to tighten that space up as well. Also try and tighten up where that it comes up through here and then reverses and goes in there. I would tighten it up around here if I could. What you really don't want to have happen is have the radiator fan be able to blow dust in any of these spaces and get dust into where the exhaust turbine is here. So use that tape liberally to do that. It won't hurt anything. Here's another spot where we have a wiring harness and that oil line, I guess same oil line again, coming through this space. We've made this so that you can flex open fingers and stuff to accommodate that if it's necessary. But once you have this going around those, I would tighten up this space with some of that tape to make sure that we aren't losing lots of air there. After you've done that, you've made it tight enough around these spaces or these little openings, then essentially it forces the air to leave the bottom here under the exhaust manifold, and we've actually got some little trap doors in those panels that don't show in the CAD drawing here, but where we want air to leave. So we want the air to enter the top back here, filter around the parts, go down to the bottom and dump out on the bottom, and I think there's a place for it to leave down on this end as well. That's okay too, although I'd force more of it to go down if I were you. It actually doesn't hurt to restrict the air leaving so that we get a pressure buildup of clean air inside there so that the dusty air can't force its way in there anywhere. So that's the patch kit. If you see one of these, or if I send you a kit, this is the aid to help you putting it on the machine itself. Hopefully the only thing you have to do to access this to put those on is to take off that perforated step above the engine. It takes about 6 or 8 13 millimeter nuts or 8 millimeter bolts to take that step off, and then you can lean over from the ladder that goes up here and do this work and put that on, and it shouldn't take too long once the parts are bent up to screw these on. Tape it up, and then you should be tighter and less risk of starting a smolder from a spark from dust that enters along this face. So be careful. Remember, you can always still have fires on your combine if you have a hot bearing or electrical short or some other source of ignition on the combine. But with this system working correctly, you should not have sparks that originate at the exhaust system. Please have a safe harvest.